This webcast discusses the lab activity where we are looking at how energy transfers from gravitational potential energy to kinetic energy. And so our objective is to determine the relationship between the gravitational potential energy of a skater and the kinetic energy of the skater as he rolls down a ramp. This lab is designed to use one of the University of Colorado simulators called Energy Skate Park. I think this should say park, not parl. Okay, so if you would go to this URL, it will take you to this page, and we want to use the measure section of this. So double click on this icon for measure, and it takes you here to the skate park. You might as well, let's check some things. I'd like to see the pie chart and the speed. We want to leave friction at none. We want to leave the gravity at 9.8 meters per second squared, which is Earth gravity. Let's see what the things told us to do here. I'm not sure if we're supposed to choose. I think you can choose whatever skater mass that you would like. I'm going to use, I think, the default value, which is 60 kilograms. But you could certainly take that anywhere from 5 to 100. But whatever you choose, you need to please write it here in your lab activity so that you will remember it. That's an important constant. And then it says the simulation tool allows you to pull up the top of the ramp to change the initial height. And it tells us to pull the ramp up as high as you can get it, which is close to 8 meters. So I'm just going to grab this end of the thing, and I'm pulling it up as far as I can. By the way, if you click on the grid, you can get an idea of the height. So I've moved it up as close as I can to the 8 meters high. Okay. Then it says place the skater at the top of the ramp. Before I do that, I'm going to change this. I'm going to click this button that has the parallel lines on it because I don't want this simulation to start running until I click the run button. This allows me to put the skater up here at the top of the ramp, and she's just going to stay there for a minute until I'm ready to pay attention and observe. Okay, so then it says run the simulation until the skater reaches the bottom of the track. And then we're going to use the measurement tool to measure the height and speed at the highest position and at the lowest position, and we're going to record these values in a table. And okay, so I'm going to let it run now so we can see the skater go down, skate down this track. And once she passes the bottom, I can stop it again. The measurement tool is this purple eyeglass here, and you can put that over one of the points, and it will give you then, like here at the top of the ramp, is her height and her initial speed. And then I can also come down here and I can put it, and I know there's no dot right immediately at the peak bottom, but I'll just take the next value, which gives her height down there and her speed. Now I'm going to create an Excel file to store my data. The lab report, or it gives you a suggested header for table 1, and these are the things that I'm going to put in my Excel file. So let's talk about setting up our Excel file to get this data. So the first thing is we're going to need the mass of the skater, and so I have made a section at the very top of my file where I've typed the mass. In the next column, I put the value of the mass. Notice that I put kilograms in the cell to the right of that. If I'm going to do any calculations with this mass, the only thing that can be in that cell is the number. I cannot put the kilogram or any other letters in there. And I also think I'm going to need the acceleration due to gravity, g, and so I have put the value of that here, and its units, of course, are meters per second, or meters per second squared. So I've made the first thing here is initial height, which will be measured in meters, and this is where I would, let's see, I'm going to go back to my skater here. I can see that in this very first run, her initial height was 7.88 meters, and her initial speed was 1.14. So her initial height was 7.88, and her initial speed was 1.14 meters per second. Okay. Now, I have here in this header, I would like to calculate the initial gravitational potential energy. And since this is a calculated field, in my report, I do want to show a sample calculation. And so that is what it's asking me to do at step 12. It says calculate the initial gravitational energy at the top of the ramp. So the gravitational energy is the mass of the skater times the acceleration due to gravity times her height. So for me, I'm using the 60 kilogram skater. Yours may be different. G, acceleration due to gravity, is 9.8 meters per second squared. The height, I'm going to look back at the table here to get the right height. It was 7.88 meters. And so if I do that math, I get an initial gravitational potential energy of 4633.44 joules. Okay? And so I want to build in a formula in my Excel spreadsheet to be able to calculate this gravitational energy. And I'm going to do that right here in the second column, initial gravitational energy. Maybe make that column just a little wider. Okay, so it's a formula, so I begin by typing an equal sign. I need to have the mass of the skater, so I'm going to click in the cell where I've stored her mass, and I need to lock that in. To lock it in, I put a $sign in front of the column and in front of the row number. Okay, so that's her mass. I multiply by G. Okay, so I have that stored, but I need to lock it in. Every time that I copy this formula, I want it to return to exactly these two cells to find the mass and the acceleration due to gravity. And then I'm going to multiply by the initial height, which was the first thing that I typed into my table. That's all it is. It's MGH, so I can hit the enter key and it has calculated it. I'm going to compare this, and look, that's exactly what I got when I calculated it by hand. So that's a valid formula. Okay. Then it also says initial kinetic energy. And let's see if there's a place to put it says calculate the initial kinetic energy at the top of the ramp. This is step 13. Well, the kinetic energy is 1/2 of the skater's mass times the velocity squared. And so the mass is 60 kilograms. At the top of the ramp, the speed was 1.14 meters per second. So that is the velocity, 1.14 meters per second. That gets squared. And so if I do this math, I get an initial kinetic energy of 38.988 joules. Now I would like to calculate this in the Excel sheet. So let's go do that. So here where it says initial kinetic energy, in this column I'm going to set up a formula. I start with an equal sign. it's 1/2 or 0.5 times the mass. So I go up and click where I've stored the mass. That location I need to lock in by putting $signs in front of the column and the row number. And then I want to multiply by the square of the speed. So I click in the cell where the speed is stored, and I do a Shift 6 to get the caret. I raise that speed to a power of 2. That's the speed squared. And I hit enter. And so Excel is giving me 38.988, and that's exactly what I got when I calculated by hand. Okay. And then it says the total energy at the top of the ramp. Well, that's going to be the sum of the EG plus the EK. Okay, so I'm just going to say equal again. I'm going to click where my gravitational potential energy is, and then I say plus, and then I click where the kinetic energy is and say enter. So that's the total energy that the skater had at the top of the ramp. Okay. Let's see. So we have done that. Then it said, calculate the final gravitational energy and the final kinetic energy at the bottom of the ramp. Okay, so I need to record in here the height at the bottom of the ramp and the speed at the bottom of the ramp. So I go back to the simulator and put the measuring tool over one of the points here at the bottom. So I see a height of 0.29 and a speed of 12.25. So the height was 0.29, the speed was 12.25. Yes, okay. Now I need to do the final gravitational potential energy. I think I can just copy this formula that I had for the initial gravitational potential energy. Let's try that. So I'm going to just do a Control-C on the cell where that formula is, and a Control-V to paste it. And let's just look at it. So I'm taking the mass stored here times G stored here times this height. So that worked. And I should be able to also calculate or copy the formula for the initial kinetic energy. So I'm going to copy that and paste it into the cell for the final kinetic energy. And let's just see. So I've got 1/2 times the mass times the speed squared. That should work. So then the total final energy at the bottom of the ramp, I'm going to put an equal sign here. It should be the final gravitational potential energy plus the final kinetic energy. Okay. So now that we have this, let's see what the next step is. Go back to my... It says calculate the percent difference between the total energy at the top of the ramp and the total energy at the bottom of the ramp. So the percent difference, let's see, the final energy is at the bottom of the ramp, and that was, for me, 4672.395 joules. The initial energy at the top of the ramp was 4672.428 joules. That's the total energy at the top of the ramp. And then I want to divide by the initial energy, which again is that 4672.428. After I do that math, I multiply by 100 just to make it a percentage, and let's see what we get. And I get negative 0.000706%. I'm going to use Excel and set up a formula to calculate this, and let's compare. So the percent difference, and I'm going to color this differently. Give it like a, there we go. Okay, the percent difference Okay, so it's supposed to be the final minus the initial. So equal, I'm going to put parentheses around it, the total energy at the bottom of the ramp, that's the final, minus the total energy at the top of the ramp, that was the initial. Close the parentheses, divide by, and I'm dividing by the total energy at the bottom of the ramp. And then I want to show this as a percent. And so I can do this. I'm going to click on the letter at the top of the column, do a right mouse click, say Format Cells. Takes just a second, and I'm going to make this a percentage with 2 decimal points. Well, maybe I'll make it a percentage with 4 decimal points. Just so I can compare with what I calculated. Okay, there we go. So 0.0007%, and that's what I had when I calculated by hand. So I think I have a good formula here. So now that I have my table set up, I should be able to just go get some more data points, and it will automatically calculate for me everything that I've set up formulas to calculate. So the way that I do this, it says change the height of the ramp to some lower value, and then repeat all those steps that we just did, and continue that until you have at least 8 data points. Okay, so I go to my simulator, and I'm going to lower the ramp. Maybe I'll put it at about 7. You're going to have to choose some points in between, okay, because we want a total of 8 points. But I'm going to go back and put my skater back up at the top. And I'm going to let her run down the track, and then I take the measuring tool and I look at the very top. Now her height was a little less, 7.18, and her speed was 1.14. So I'll go to my spreadsheet and I put 7.18 as the height and 1.14 as the speed at the top of the ramp, and then I'll bring this down here to a point at the very near the bottom of the ramp, and I see a height of 0.03 and a speed of 11.89. Okay, so I can just copy these formulas down below, and it just automatically copies for me. And so it is calculating the gravitational and kinetic energies at the top of the ramp and the total energy at the top of the ramp, and it's also doing that at the bottom of the ramp, and it's calculating the percent difference. So I'll continue doing this until I have a total of 8 data points. By the end, you can't get lower than 4 meters. So all 8 points have to be between 8 meters and 4 meters. Okay, so that's why you can't just go down 1 meter at a time. Don't worry, your data does not have to be at even increments of the height of the track, but we do need at least 8 data points.